Bienvenidos, Ushamdi, and welcome CTS230 Section 841 students for the Fall 2017 semester, first 8-week term at Anne Arundel Community College. This is the Scaling Networks V6 or Networking 3 course, and this evening's video tutorial and solution set is going to be on Packet Tracer Activity 2.2.3.3, where we're going to be troubleshooting VTP and DTP, in other words, the VLAN trunking protocol and the dynamic trunking protocol. So let's go ahead and come over to our activity. Again, 2.2.3.3, I'm using Packet Tracer version 7.1, and here is our addressing table over to the right-hand side here. So let's go ahead and dive in, and this is a nice activity. It kind of walks us into and through a number of things we need to be looking at here. So in part one, you're going to troubleshoot the trunk links among the active switches. Verify, or you will verify, that permanent trunk links are used between the switches. So let's go ahead and starting with switch 2, let's take a look and see exactly how the trunk links are configured. Again, the text is a little small, so I will go ahead and definitely sort of provide you with a play-by-play here. So we're going to go from user exec mode with the enable command. We're going to move into privilege exec, and I'm going to say show interface trunk, because again, we're checking to see what the status is of the links between the switches. As you can see here, we get nothing back, right? So this is typically an indicator that the port actually, so it's going to be probably one of the gig ports here, is simply misconfigured. So let's do a show run, and we can work our way down to the gig ports. And you can see we've got interface gig 01 and then interface gig 02. Now, gig 01 is set up with switch port trunk native VLAN 999 and switch port mode access, right? And so we know right away that gig 01 is probably not an access port. It's probably the trunk port. So here's a great way for us to check, and let's get into global config. If I go into interface gigabit Ethernet 01 and I say shut, you can see that the port has gone red. And the reason I did that is because we want to conclusively prove that this port between switch 2 and switch 1 is gigabit Ethernet 01. And now that we've seen that, we can say switch port mode trunk, and if I were to say do show run, we'll see that it's now a trunk port. And it is now set to the native VLAN 999. Let's also go ahead and say switch port no negotiate. We'll turn DTP off on that port, and I'll say no shut and bring that port up. Now, you can see we've got this native VLAN mismatch with switch 1. And we can clearly see here that it's switch 2 is gig 01, the native VLAN is 999. On switch 1, the native VLAN is 1. So let me quickly reference the diagram here, and let's see if it gives us any indication as to what the native VLAN should be. And I'm just reading through here real quickly, trying to see. And I don't see anything listed. So we'll go ahead and match, and we'll make it 999. So let's pull up switch 1, and you can see we've still got some what appears to be spanning tree activity there, right? Waiting for spanning tree to fully converge on that port. And that's exactly what's happening. Take a look here. Spanning tree blocking PVID local, right? Because so inconsistent port type. So let's take a look. Let's go from user exec, and we'll type the enable command and go to privilege exec, where we say show interface trunk. And you can see again here, no trunk ports. Let's say show run. And you can see that gigabit Ethernet 01 is switch port mode access. Now, gigabit Ethernet 02 is also switch port mode access, and so I'm pretty sure that gig 02 is going to be going to switch 3. So let's go ahead and take care of both of these issues here by saying interface range gigabit Ethernet 01-2, and I'm simply going to say switch port mode trunk, and then we'll say switch port no negotiate, because again, we'll go ahead and we'll turn DTP off. We're going to hard code these as trunk ports. So now that we've got that configured, we'll say do show, I'm sorry, before we do that actually, let's go ahead and say switch port trunk native VLAN 999. So we're going to match the native VLAN on both sides. So we'll type in write mem to save our config. You can see that our light is now blinking green. Show interface trunk shows exactly what we would hope it would show, which is gigabit Ethernet 01 and 02 are both in the on mode, and on mode meaning that we have hard-coded them as trunks. The encapsulation is 802.1q, which is automagic here on these 2960s, and the status is trunking with a native VLAN of 999. All right, now let's go ahead, and interestingly enough here, you can see our completion percentage right now is at 0%. So let's hope that we're not dealing with some sort of a bug here, whoops, with Packet Tracer. So we'll transition to the CLI. You can see we were getting an error, or we did just get an error. So let's say show run, and we'll go down and look at gigabit Ethernet 02. You can see switch port mode access here again, but we need to validate on switch 3, and let me slide this a little bit more to the side. So let's go from privilege exec into global config with the configure terminal command into interface gigabit Ethernet 01. And I'm going to say shut. Well, you can see that the port did not change, right? The port here on switch 3 stayed lit green, so it's got to be gig 02. So if I go to interface gigabit Ethernet 02 and say shut, you can see that that's definitely the port we're working with. So we're going to want to say switch port mode trunk. We'll come back with switch port no negotiate as well, and then switch port trunk native VLAN 999, which I think may have already been on there, but we'll roll with it anyway. And then we'll say no shut. We're going to bring that port up, and we're going to allow spanning tree to converge and to transition through the listening and the learning, and then the forwarding, ultimately into the forwarding state. So if I say do show interface trunk right now, the ports are still orange, but we get what we're looking for in terms of the trunk output. However, the very last line, VLANs and spanning tree forwarding state. And again, remember, we talked about the criticality of this last section of output here. Very important, because that's going to tell me which VLANs are forwarding over that trunk link. And here you can see we've got 199 and 999. So very good possibility here that we've got some VTP issues, which we're going to be troubleshooting in turn. So again, we took a look at the operational modes, we corrected the trunking issues, and we verified all the trunk commands. So now let's troubleshoot VTP, the VLAN trunking protocol. So switch 1 should be configured as the VTP server. And so now that we have the trunk links sorted out, we can go ahead now and step into the VTP configuration. Now let's go ahead and take a look at this. It should be the VTP service. Let's say show VTP status. That's going to show me the current status. You can see that I'm in transparent mode. So it should be the server. Switch 2 and 3 are going to be clients, and they're going to be receiving updates from switch 1. It gives us the domain name, the password. It doesn't say anything about the VTP version. You can see we're running version 2, so we're going to stick with that. So let's go ahead and say do show VLAN brief, and you can see we have VLAN 10, 20, 30. Those are staff, faculty, or staff, student, and faculty, respectively, 99 and 999, so management, and then just simply 999, which is our native VLAN. So let's go ahead and make the changes here. So VTP mode, whoops, say VTP mode server. We're going to say VTP domain, CCNA, and then VTP password, Cisco. All right, so let's do a write mem and save our config here. Now we say show VTP status, and you can clearly see that things have changed. It's a VTP server with a domain name of CCNA. If I say show VTP password, the password is Cisco. So now let's transition over to switch 2, where we're going to say show VTP status, and we're interested in seeing what is the current configuration. So we're in transparent mode here. So let's get to global config with a configure terminal command. And I'm going to say do show VLAN brief because we want to see which VLANs I have here. And again, take a look at that. I don't have 10, 20, and 30. Well, let's change the VTP mode to client, the VTP domain to CCNA, and I'll do that in all caps, CCNA, and the VTP password to Cisco. So now what we should see happen here on switch 2 is I should receive a VTP advertisement from switch 1, and then I should get what's referred to as that summary, but it's not really a summary because it's got all of the information that we need. And I was waiting a second there before I said show VLAN brief, and take a look. 10, 20, 30, we are set, right? So we'll do a write mem again here just to make sure. And interestingly enough, our completion percentage has now decided to move off of 0. So let's go ahead and do the same thing here on switch 3. We know we're missing the VLANs already. So from global config, I'll say VTP mode client, VTP domain CCNA, and VTP password is Cisco. All right, so we'll say in, we'll do a write mem here. Our completion percentage has jumped to 45, and show VLAN brief, we've got everything we need. If I say show VTP status, you'll see that we were updated, and actually the configuration modified by is still zeroed out there over here. Show VTP status, we should see, and actually we're not seeing any changes. Let me do this. Let's come over to switch 1 here. Let's see, I'm going to force a change. Let's get into global config, and I'll say VLAN 999 name native, because we're using that as our native VLAN. And then how about VLAN 888, and I'll say name parking lot. So again, this isn't required. I'm just throwing some things in here to increase the configuration revision number so that we can see when we say, for example, here on switch 2, show VTP status, I should see, and that's what I'm looking for right there. You can see that we've been updated. Configuration last modified, right? And that is what we're looking for. The configuration revision number is 3. And if you think about it, that makes sense, right? We renamed VLAN 999. That was the first configuration revision change. We created VLAN 888. That was the second configuration revision change. And the third configuration revision change was when we named VLAN 888 parking lot. All right, so let's come over here. We're only at 45% for right now, but let's work our way down here. We did the show VLAN brief. We corrected the VTP. Now we've got some port assignments. And if you take a look at this, now this activity mirrors one of the first activities we did here for chapter 2, which I cannot recall. And actually, let me pull up. Here we go right here. 2144. When we did our configuration work for packet tracer 2144, that was where it said switch 1 instead of switch 3. But now take a look at this activity. So again, this activity is confirmation that it was a mistake in that 2144 activity, where in the table for the port assignments it said switch 2 and switch 1, or switch 1 and 2. I can't remember which was listed first. But irrespective of the order they were listed in, it should not have been switch 1, because when we look at our diagram here, does switch 1, and where did our diagram go? Kind of rolled off the screen on us. And where did that go? And this might be a minor bug here. What did I click? I must have hit something there. So again, I'm not sure what I hit, but when we look at it, switch 1 has no clients, right? So switch 2 and switch 3, that's where we're going to focus our attention. So on switch 2, let's go ahead and get into global config with the configure terminal command. We're going to go ahead and say, and this is only showing a single port. So interface fast Ethernet 01, we're going to say switch port mode access VLAN 10 for the staff VLAN. And what we also want to do is, what about a spanning tree port fast, right? We know that's going to be a host. And so since we know it's going to be a host and we can skip the listening and learning states of spanning tree and transition directly to the forwarding state, we also want to protect ourselves against switching loops. So spanning tree BPDU guard enable, right? So definitely a good command, two good commands to add on ports that we know are going to be host-facing ports. And so that's what our port looks like right now. So let's go now next to interface fast Ethernet 09, and we're going to do much the same thing. Switch port mode access, switch port access VLAN 20, and we could again say spanning tree port fast and then spanning tree BPDU guard enable. Interface fast Ethernet 017, interface fast Ethernet 017, and then the same thing, switch port mode access, switch port access VLAN 30, and I'll leave the spanning tree BPDU guard off of there for right now. And then we come over to switch 3, and this is sort of going to round out this activity. Again, very straightforward what we need to be doing here. Interface fast Ethernet 08, switch port mode access, switch port access VLAN 10. I'll leave the BPDU guard and port fast off, obviously not required. Interface fast Ethernet 016, switch port mode access, switch port access VLAN 20. And then finally, interface fast Ethernet 0/24, switch port mode access, switch port access VLAN 30. And that takes us from that 90% up to 100%. Now the final check, and we're not actually going to be able to do this because the diagram for the activity has disappeared completely off the screen, and I am clicking around here. I don't know where the diagram went. All right, but irrespective of the diagram being gone, we would have connectivity between all those PCs, and you can see that our completion percentage has reached 100%. So again, to recap, right, we troubleshot DTP. We saw that the ports cannot be set to switch port mode access. Remember, that overrides any of the commands that are on the port that indicate that it could be a trunk port. And when you have an access port between the switches, this is critical. If DTP says that's an access port, or if it's hard-coded as an access port, if it's hard-coded as an access port, DTP is off, right? But if it's hard-coded as an access port, whatever the VLAN is, if it was VLAN 1, which it was in our case, all you're doing is extending the broadcast domain of VLAN 1 over to, we'll say this is switch 2 and this is switch 1. You're just simply extending the broadcast domain or adding more ports into the VLAN 1 broadcast domain. And so we need to make sure we're very, very aware of that. I didn't run these show interface fast Ethernet or gig01 switch port command, but remember that show interface, the interface designator, and then switch port. Very, very important command because it allows you to see what the administrative mode is and what the operational mode is, right? So we troubleshot the DTP problems. We also hard-coded switch port mode trunk and then said switch port no negotiate to turn DTP off. Not required, but definitely a best practice. And then we troubleshot VTP, the VLAN trunking protocol. But really, it really wasn't troubleshooting, was it? So we kind of knew what we needed to set up there. So it was more of a configuration exercise and then ensuring that we had all the VLANs that were required, and we did. All right, well, this is going to wrap up Packet Tracer Activity 2.2.3.3, troubleshooting VTP and DTP for, again, the fall 2017 semester CTS230. Thanks so much for watching, and I'll see you guys in the next video.